Today's lesson, section 7.1a, we're talking about trigonometric identities. So before we begin proving identities or verifying that identities are correct, we need to be able to have a list of identities to start using. So these are just the fundamental trig identities that we'll start with and we'll add on as we move through the chapter. Now some of these you've already seen, so like the reciprocal identities, you already know that cosecant is the reciprocal of sine, so it's 1 over sine x. Secant of x is 1 over cosine x, and cotangent is 1 over tangent x. Also, tangent of x is the same thing as sine over cosine x, and cotangent is the same thing as cosine x over sine x. Some ones that we introduced but we haven't really quite used yet are the Pythagorean identities. So a main one that we use is sine squared plus cosine squared equals 1. That comes directly from the unit circle, and all these do. But sine squared, if you think of sine as y and cosine of x as x, so you really have y squared plus x squared, and it is equal to, if you're on the unit circle, your r squared is 1. So that's really where that basically originates from. And then all of the other ones, tangent squared plus 1 equals secant squared x. That comes from the unit circle. And then 1 plus cotangent x squared x equals cosecant squared x. Also some ones that we've already talked about are the even odd identities. So if you have a negative angle for sine, then that's the same thing as negative sine of x. Cosine is even, so remember that when I take the cosine of a negative angle for x, then it's cosine of x. So it's the same thing as the positive of that angle. And then tangent of negative x is the same thing as negative tangent of x. So sine and tangent are odd properties, or odd functions. And then cosine is an even. Some newer ones are the cofunction identities. So this is just saying that, like, if you talked about or remember from our trig graphs that we were drawing, sine is just if you shifted it over, or your angles over by pi over 2, then you would get the cosine function, so cosine of u. And then vice versa, if you shifted over cosine 90 degrees, then you would get sine. Same thing for tangent and cotangent. If you shifted them over, then you would get the opposite. And then same thing for the secant and cosecant functions. Okay? So for example 1, we want to be able to verify that both sides are equal to one another. So to deal with this one, it says cosine of theta is times secant theta minus cosine theta is equal to sine squared theta. Now, generally how I tackle verifying equations or any identity is that I kind of deal with just one side, and it would actually be very helpful if when you did this, you pick a side and you use your identities to manipulate that side to help you get it look like the other side. Please don't mess with both sides at the same time. It's kind of hard to follow, plus it kind of gets confusing at a certain point. So if you would, just pick a side and mess with that first, and then if you need to like change another side, do that in another step. So keep those two things separate for me, and that'll make it a lot easier to keep your thing straight, and then it'll be easier to see your work as well. So here I usually pick the side that like looks like it has something to change. If I look at the right side, sine squared theta, it's pretty simplified, so I don't need to really change this one. So I'm going to mess with the left side, where I have cosine of theta and secant theta minus cosine theta. Here, anytime I see a value outside parentheses, that just tells me that I should distribute to see what I get. Okay, so then I'm going to multiply cosine theta through, so cosine theta times secant theta, and then since it's cosine times cosine, I get cosine squared theta. Okay, and so then from there, secant and cosine are like kind of reciprocals of one another. So cosine theta times 1 over cosine theta, that's one of our reciprocal identities that we just talked about. And so then here you have cosine theta times 1 over cosine theta. They actually cross each other out, leaving you with 1. Now here, anytime I see squares, I always go back to my Pythagorean identities because they're the only identities that have any squares. That would help me out. So if I think about the one that involves sine and cosine, let me scooch that over and put a different color. So cosine squared plus sine squared equals 1. So if I manipulated this a little bit, and move cosine over to the other side, that gives you sine squared equals 1 minus cosine squared theta. So that means that this is equal to that. So I can insert in sine squared to the left side because of that movement around, and then that gets me sine squared equal to sine squared. So you're really not complete until you have a statement at the end where it's the same exact thing on both sides. You can't stop here and say it's good because you know the identity. You need to use the identity to insert it in to show both sides are the same. Okay? And then you are finished with that problem. Okay. Now letter B says that 2 tangent of x times secant of x is equal to 1 over 1 minus sine x minus 1 over 1 plus sine of x. So here, anytime I see fractions, I know that it probably makes sense to put them together, because looking at from the right side to the left side has no fractions. They're all one thing multiplied. So it probably makes sense to work with the right side because I can easily make common denominators and put them together. So for this one, I'm going to mess just with the right side. So to make these fractions go together, I need to make common denominators. So I need to multiply the left fraction by 1 plus sine of x. And then the right fraction needs to be 1 minus sine of x. Because remember that these are two binomials, so they're completely different. Even though they share a 1 and a sine of x, because they're not the exact same binomial, that means they're completely different. So that's why I'm doing this and not just saying add 1 to one side or something like that. Okay, so I made my common denominators. So 1 plus sine of x. And actually, before I multiply, I'm going to change this negative sign to plus and move the negative sign up. It'll make it easier for me later. So now that I have common denominators, it's 1 minus sine of x times 1 plus sine of x. And then I get plus, and negative 1 times 1 and negative sign gets me negative 1. Okay, so now I have some simplification to do. So on the top, the 1's cancel each other out. Okay, so it leaves me with 2 sine of x, because those are like terms, so I can add them. So 1 sine of x plus 1 sine of x gets me 2 sine of x. And at the bottom here, I need to do my FOIL method. So then 1 times 1 gets me 1. 1 times sine gets me sine of x. Negative sine of x times 1 is negative sine of x. And then negative sine of x times sine of x is negative sine squared of x. So here, your signs cancel at the bottom. So I have 2 sine of x over 1 minus sine squared of x. Okay? So now, think about your Pythagorean identity. So, since I have a sine squared here, I know if I have sine squared cosine squared equals 1, I could rewrite this and say sine minus sine squared to both sides. So then cosine squared would also equal 1 minus sine squared theta. Okay, and you can really do that with all 3 Pythagorean identities to make them match so they fit what you want them to fit. So there's really 3 forms for each identity. So you really have 9 identities scrunched into one starting point. Okay, so because I can say 1 minus sine squared, I can plug that in. Okay, so then cosine squared x. Okay, now here, this is the point where, like, well, there's not much left to simplify, but I still don't have what I want over here. So I want you to look at the other side. Okay, so try to notice what's special about this identity over here, okay, and try to match or make the right side match. So here you have a tangent and a secant, okay. Now how could you get a tangent from sine over cosine squared? Okay, you already got the 2, so you can easily move that to the front if you'd like. But if you look at your identities, tangent is sine over cosine, and you have a sine over a cosine, so you can rewrite this fraction into 2 separate fractions. Also, secant is 1 over cosine, and because you just need a sine over a cosine to make tangent, you got this extra cosine that needs to go somewhere. Well, that's why they have a secant. It's because it was 1 over cosine to begin with. And so then now, if you rewrite them, you get 2 tangent of x secant of x or is equal to 2 tangent of x secant of x. And then you're done. Okay? Now we'll do a lot more of these in class and through the videos, just so you can get a good idea of how identities work and how we verify them all the time. And so hopefully after doing this one, you need a lot of practice to get good at it, because it doesn't just come naturally to see where identities go and where they should be put. So you kind of have to practice on this one. Okay? Have fun.